Dear students, now we are going to see the course Signals and System. Under that, the topic is a transform. Upon the completion of the topic is a transform, the students can able to apply the is a transform on discrete time signal for solving the engineering problems. Is a transform is a transformation of x of n as x of z, that is summation n equal to minus infinity to infinity x of n z power minus n. And similarly, the inverse is a transformation of x of z as x of n, that is equal to 1 by 2 pi j integration over the closed contour x of z power n minus 1 into dz. Some of the inverse is a transformation problems by using, we are going to see some inverse is a transform problem using partial fraction. So here the given is x of z is 1 by 2 z inverse divided by 1 plus 1 by 2 z inverse plus 1 plus 1 by 18 z power minus 2. So to make the positive power of z, multiply the numerator and denominator by z square. So we are getting x of z equal to 1 by 2 z by z square plus 1 by 2 z plus 1 by 18. Then factorize the denominator by using the formula z equal to minus b plus or minus square root of b square minus 4ac by 2a. Here the a represents the coefficient of z square term in the denominator and b represents the coefficient of z term in the denominator. C is the constant coefficient, that is 1 by 18 in the denominator. Substitute all the values and you simplify this. You are getting z equal to minus 1 by 6 is one of the factor and z equal to minus 1 by 3 is another factor. Substitute this factor in the denominator of x of z. So we are getting x of z equal to 1 by 2 z plus 1 by 3 and z plus 1 by 6. So cross multiply the z in the numerator with x of z by z. So the term becomes x of z by z is equal to 1 by 2 divided by z plus 1 by 3 into z plus 1 by 6. Apply partial fraction. So this is equal to a by z plus 1 by 3 plus b by z plus 1 by 6. Find the characteristic equation. You take an LCM. So we are getting the characteristic equation is 1 by 2 equal to a into z plus 1 by 6 plus b into z plus 1 by 3. Find the a value. Substitute z is equal to 1 by 3 in the above equation. So we are getting a is equal to minus 3. And find the b value. Substitute z is equal to 1 by 6 in the characteristic equation. So we are getting 1 by 2 equal to b into minus 1 plus 2 by 6. So b is equal to 3. Substitute the a and b value. So x of z by z equal to minus 3 by z plus 1 by 3 plus 3 by z plus 1 by 6. Now cross multiply the z in the denominator of x of z with the numerator. So x of z equal to minus 3z divided by z plus 1 by 3 plus 3z divided by z plus 1 by 6. Apply the inverse z transform on the above equation. So we are getting z inverse of x of z, that is equal to z inverse of minus 3z by z plus 1 by 3 plus 3z by z plus 1 by 6. So z inverse of x of z is x of n. Here the minus 3 is constant, so minus 3 z by z plus 3 is minus 1 by 3 the whole power n into u of n. In the second term 3 is constant, z by z plus 1 by 6 is minus 1 by 6 the whole power n into u of n. Then find the inverse z transform of x of z using Cauchy residue method. Given x of z equal to z cube divided by z plus 1 into z minus 1 the whole square. Here z plus 1 is a single pole and z minus 1 the whole square is a multiple pole. If it is a single pole, the x of n value is determined by x of n equal to summation I equal to 1 to n z minus that particular pole x of z power n minus 1, then z equal to that particular pole pi. And for multiple poles, x of n equal to 1 by k minus 1 factorial d power k minus 1 by dz z minus that particular pole power k times x of z power n minus 1 at z is equal to that particular pole. So we substitute this formula in the given x of z. So our x of n is z plus 1 into z cube divided by z plus 1 into z minus 1 the whole square into z power n minus 1. Here z equal to minus 1. That is for the single pole z equal to 1. Z equal to minus 1. Then for the multiple pole the x of n is d by dz of z minus 1 the whole square into z cube divided by z plus 1 into z minus 1 the whole square into z power n minus 1 z equal to 1. Here in the first case simplify this, and z equal to minus 1 for single pole and z equal to 1 for multiple poles. Substitute this assumption, so we are getting x of n is z cube divided by z minus 1 the whole square into z power n minus 1, where z is equal to minus 1, and d by dz of z cube by z plus 1 into z power n minus 1 z equal to 1. And simplifying this, we are getting z power 3 plus n minus 1 divided by z minus 1 the whole square z equal to minus 1, and plus d by dz of z power 3 plus n minus 1 by dz into z plus 1 z equal to 1. So z power 3 minus 1 is 2. So z power 2 plus n by z minus 1 the whole square z equal to 1, plus d by dz of z power 2 plus n by z plus 1 z equal to 1. First term substitute z equal to minus 1. So minus 1 the whole power 2 plus n by minus 1 the whole square, plus d by dz of z plus 1 the whole power minus 1 z power 2 plus n z equal to 1. So x of n is minus 1 the whole power 2 plus n minus 2 the whole square plus minus 1 into z power 2 plus n plus z plus 1 the whole inverse into 2 plus n z power 2 plus n minus 1 z equal to 1. Substitute this value, it is equal to 1. So minus 1 the whole power n divided by 4 into u of n minus u of n plus 2 plus n by 2 into u of n. Quiz question: what is the set of value of z for which x of it is z attains a finite value, that is the radius of convergence? Thank you.